Hi, in the previous video, we discussed the product of two binomials. In this demo video, we're going to discuss the product of special binomials. So on your screen, you're going to see three binomial pairs. So we're going to discuss how to multiply these products. All right, first let me point out what's special about these binomials. Um, On the leftmost side, you're going to see a pair of binomials, but they are connected. The first binomial is connected by a plus sign. The second is connected by a minus sign. So you have plus and minus. The signs are not the same for the two binomials. Let's see what happens when we multiply these two binomials. All right, you'll see in the first step, it just did FOIL. Remember from the previous video, we said that when we get the product of two binomials, we just do FOIL. So we multiply the first terms, x times x will give us x squared. We multiply the outer terms, x times negative x will give us negative xy. The inner terms will give us positive yx, and the last terms will give us negative y squared. All right, now for graspable math, we have to make sure that these two are exactly alike. They're alike. We can rearrange these in such a way that they will look the same because we need like terms, all right? So I just interchange the positions of x and y, applying the commutative property of multiplication. Now, this is xy, this is also xy. That means we can combine them because they're like terms. All right, and that's the final result. Now let's see the intermediate step, the one that was not shown. So after I rearrange the terms here so that they will be like terms, I combine them, and since they're the same except for the sign, they will cancel each other. So you get a 0. Now you can take out that 0 and express your final answer as x squared minus y squared. There's a special name for this product that's called a difference of two squares. It's a difference of two squares because you have the first term is a square and the second term is also a square, and they're connected by a minus sign. So that's a difference of two squares. So that's the result of multiplying a plus and a minus, two binomials that are connected by different signs. All right, now let's go to the next special binomial here. We're going to apply FOIL first. All right, it didn't happen, right? What happened? These are two equal binomial factors. See, as you can see, the signs are the same. Both of them are plus. Unlike the one here, one is plus and the other is minus. Here, they're both connected by plus signs. Since they're exactly the same, it can be rewritten as what we call binomial squared. So this is a binomial squared. Now, there's a special way of expanding a binomial. Let's do that. All right. So when I click the exponent, it expanded the binomial, which we could have also obtained from the original. If we did FOIL on this, which this app did not do, we could have arrived at the same answer. See, if we multiply the outer terms here, x times y, we're going to get xy. And if we multiply the inner terms, we're going to get xy also. If we combine the two xy's, then you get 2xy as the middle term. And that is how you expand a binomial squared using the shortcut. You don't have to do FOIL on this problem. It can be expanded using the shortcut. And this is how the shortcut goes. You square the first term, so that gives you x squared. Now, the result is a trinomial. All right, this is a trinomial, not a binomial, unlike this one. There is a middle term, and this is what students usually forget when they expand a binomial like this. Many students omit the middle term, but there is a middle term, all right? they don't cancel out like this one. They don't cancel out. They get added. All right, because they have the same signs, xy and xy. So that becomes 2xy. So that's the middle term when you are expanding a binomial. And then the last term is simply the square of the second term. So just to summarize the steps, you square the first term, and then you get twice the product of the two terms. So that will be xy times 2 or 2xy, and then you square the last term. Now on the right side, you have almost the same problem, except that these are now connected by minus signs, both of them. Here, the binomials are connected by plus signs. But the process is the same. All right, let me show you. See, it was converted into a binomial squared, just like what happened here. Now, if we apply the exponent, there. If we apply the exponent to the binomial, then it expands this way. Now, these two are called perfect square trinomials. All right, this is the special term that's used for these two products. These are called perfect square trinomials. They're trinomials because they have three terms. Perfect square because the first and the last terms are perfect squares. And the middle term conforms to a certain formula, which is twice the product of the two terms. So this is a perfect square trinomial. This is also a perfect square trinomial. The only difference between these two is the sign of the middle term. They follow the sign of the original binomial. If this is plus, then the middle term is plus. If it's minus, then the middle term is minus. All right, let's do some examples which have numbers in them. So this is one example. So let's do FOIL first. All right. So that was simply FOIL. Let me show you. All right. If you multiply the first terms, you get 4x squared. You multiply the outer terms, you get negative 6x. If you multiply the inner terms, you get positive 6x. And if you multiply the last terms, you get negative 9. Now, as you can see, the two middle terms are exactly the same, except for the sign. So they are like terms, and we can combine them. Let's do that. All right, see what happened. Now, there's an intermediate step here, which is hidden. So when you add negative 6x and 6x, you get a 0, and you can get rid of the 0. So this is, again, what we call a difference of two squares. The difference of two squares is a binomial. Both terms are perfect squares. So 4x squared is a perfect square, 9 is a perfect square, and they're both connected by a minus sign. So this is what we call a difference of two squares. Now let's try this one. Remember, the special product that results from this is what we call a perfect square trinomial. Let's do FOIL first, or let's attempt to do FOIL. All right, instead of doing FOIL, this math change it into a binomial squared. All right, since these are exactly the same, you can rewrite this as a binomial squared. Now we'll expand this using the shortcut. All right, it's almost done, except that we have to simplify this. But let me comment on this stage. Remember, when you are expanding a binomial squared, you square the first term, so that's 9x squared. And then there's a middle term, which is twice the product of these two terms, right? So the product is 3x times 2, which is here, 3x. By the way, this is x and not a multiplication symbol. So you're multiplying 3x and 2, and then you multiply that product by 2. Remember, the middle term is twice the product of these two. So this step shows that. And then the last term is simply the square of the second term. Now we can just simplify this. We will put the numbers together. So there. So this is the final form. All right, this is the final form. So if we apply the shortcut to this expression here, we simply do it this way. We square the first term, which is 9x squared, and then we get twice the product of these two terms. The product is 6x times 2, so we get 12x. And then the last term is the square of the second term. So there. So this is a perfect square trinomial.